So geometry, here we go on our video crusades. 6.3, prove triangles are similar by AA. Okay, now notice we're doing similar triangles, not congruent, and we have two angles, because we know that if we have two angles, we automatically get the third by using the triangle sum theorem, because you add up all three angles equal 180, so if you know two of them, you can find the missing one. I can use angle-angle similarity postulate, and I can use properties of similar triangles in real-world situations. I am armed with my protractor, so we'll need that a little bit later for, shouldn't say key vocabulary, but should just say, I don't know, experiment, I guess. In any case, here we go. I don't want to change that and type up another one of these. So, in triangle ABC and triangle XZW, with the measure of angle A is equal to measure of angle X. Okay, I'm not sure why I didn't say congruent. I just said the measures, it's fine. Measure of angle B is congruent or equal to Z. And what can you include about the measure of angle C and the measure of angle W? Well, the measure of angle C is equal to the measure of angle W. Or you could switch this to angle C is congruent to angle W by the definition of congruent angles. All right, moving on. Solve this proportions. Let's cross multiply. 9x is equal to, please double check my math, 972. Divide both sides by 9. X equals 108. So far, so good? Okay, so let's find, these two triangles are similar. Let's find x. Well, AB corresponds to DE, which is right here. We don't know what that is. And BC corresponds to EF, which is right here. Well, the problem is we have two unknowns. So technically, you can't do this. However, what if we say this? Triangle ABC is similar to triangle DFE. Now, AB is 8, DF is 20, BC is X, FE is 6. Now we can cross multiply. So you've got to be really careful. I like doing that. So 20x is equal to 48. Divide both sides by 20, we get 2.4. So be really careful. Check that similarity. Of course, these look like they're similar, but trick question. All right, so we have a little experiment here. What can you conclude about two triangles if you know that two pairs of corresponding angles are congruent? Okay, so draw a triangle EFG so that measure of angle E is 40 and the measure of angle G is 50. So it doesn't matter how long we're going to make this segment. I think I said use a metric ruler. Yep, right here. So we're going to make this just 3. So there's 1, 2, 3 centimeters long. You see that? And I'm going to call this angle E. Take out the, this is kind of bent. I don't know if you can see it, how bent it is. Okay, let's see if we can make it work. Okay, we need this to be 40 degrees. 40 is right there. Okay. And then we need angle G to be 50 degrees. Would be right there. And so this would have to be F right here. All right, so now let's do the same thing for RST. Now remember, I purposely made this 3 centimeters. It doesn't really matter how long you make it. I'm just going to make this one 6 centimeters. Just double it. Makes life easier. And we have to do angle R. So look at, we just did angle, angle. And I'm not saying angle, 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 side angle because this has a different side length. So I want to do the same angle, 40 degrees. Yeah, this takes time. This is going to be like the biggest part of the video today. So that's not too bad, right? And then angle T will be 50 degrees. Yeah, this might be something that you want to kind of pause it, go through it. Six centimeters. And now calculate angles F and S. Well, if this is 90, that has to be 90. Same here. So these two triangles have the same angle measures, but they're obviously not congruent. Okay, so they are similar. And it says use a protractor to check that your results are true. So should we check that, make sure that this is a right angle? And it looks pretty good. Looks pretty good. Okay, now measure and record the side lengths. Okay, so that was 3. So this is about 2.5. Because it goes 1, 2.5. This one is about 2. That makes sense because a bigger angle will have a bigger side length. Okay, this is about close to 5. I'm going to say about 5. And I'm trying to measure these, hopefully. And this is about 4. What do you notice? All right, well, are the triangles similar? Yes. The angles are congruent, and the sides are proportional. Okay, from a 1 to 2 scale. Okay, now obviously I was off a little bit, so there could be a little bit of human error. That's okay, I'm trying to go fast, but that was a long part. Compare your results with your classmates, making a conjecture about the two triangles with 2 paracongruent corresponding angles. So the conjecture is, if you have 2 corresponding angles, the third one will fall into place, the triangles will be similar. Okay, next page. You ready for this? It goes fast now. So here we go. Angle similarity postulate. Hopefully this comes out nice when I photocopy it for you. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So they just have this angle and then this one, this angle, and this one. So the triangles are similar. Notice we're using similarity, not congruence. Okay? These are similar. Okay, to determine whether the triangles are similar. If they are, write the similarity statement. Well, what I'm going to do is add these two up. I have 132, take away from 180, I get 48. So 180 minus 30 plus 102 is equal to 48. And how about these two? 102 plus 48, this one will be 30 degrees. Are they similar? Yes. Okay, so we got to make sure we match them up right. Triangle EFG is similar to triangle. Okay, now E is 102, so I have to say L. I went F second, so M, N. Go figure. Okay, so not too bad. Show that the two triangles are similar. Alrighty, see the parallel lines? That means these are corresponding angles. And I'm going to split these triangles up. So D, B, E, and I know this angle, and then A, B, C. Remember, these were the corresponding angles, and then they both have angle B. So these are similar by angle similarity. How about these two? Okay, if you have parallel lines cut by transversal, alternate interior angles are congruent. Okay, and also we have vertical angles. vertical angle, A-N-G-L-E-S. Sorry. So we have AA also. So far, so good. How about C? Again, we have vertical angles. We'd have to state all right angles are congruent. So we have angle, angle, similarity. And last but not least, let's see here. I'm going to split these up. This is 60. Now, if this is 100, remember this is a linear pair. This has to be 80. And then 60 plus 80 is 140. This will be 40. What do you notice? These two angles are congruent. Okay, now let me draw the whole big thing. This is 40. And it shares this top angle at A. Look at angle, angle. Let's make A's out of that instead. Angle, angle, similarity. Okay, so these are corresponding angles. How about that? All right, last page, and we're done. Woo! Cranking out videos. Ooh, a flagpole. Used in real life situation. Cast a shadow that's 85 feet long. Jacob cast a shadow that's 10 feet long. If Jacob is 6 feet tall, how tall is the flagpole? Well, here's my small triangle. 10 feet, 6 feet. And then here's the larger triangle. Obviously, we have a little issue here. This is 85. Just set up a proportion. I'm going to go from big to small. So, x to 85 is equal to, x to 6. Silly me. X to 6, 85 to 10. Okay, big to small, big to small. Cross multiply. Okay, 85 times 6 is 510. Please double check. X equals 51. And please put a unit down there if we're talking about units. Now, what if I didn't set it up big to small? What if I said x to 85? So if I go this way, so height to length, I have to do height to length. What's going to happen? 10x is equal to 510. So you'll end up getting the same thing depending on how you set it up. But just make sure, however you set it up, the ratios will be similar. Here's our homework assignment. And use properties of similar triangles transformation. Okay. Can you construct similar triangles using angle, angle, similarity? We actually just did it in that little activity earlier today. So have a good evening.